So let's take a look at this question together. It says that a mass is suspended from a spring that is oscillating up and down as indicated. Consider two possibilities. At some point during the oscillation, the mass has zero velocity, but its acceleration is accelerating, positive or negatively. And the second choice is that at some point during the oscillation, the mass has zero velocity and zero acceleration. Well, in both cases, we want to know where the zero velocity is because they both deal with zero velocity. So, in a position versus time graph, the slope of the position versus time is equal to our velocity. So I want to know, when does the slope go to zero? Well, I see at the very top here, this slope is 0. Down at the bottom, this slope is 0. And at the top, that slope is 0. So these are my velocity equal 0 positions. And we want to know what's happening to the acceleration during these points. Let me grab out a new color, and we're going to look at the acceleration. Well, the acceleration, if I look at this first point, the velocity was positive, right? It's going more and more towards a positive z, so it has a positive velocity. But as soon as it gets up to z, it turns around and starts going back. So this is going to be v greater than 0, and this is actually going to be v less than 0, which tells me that at the very top, the acceleration is not equal to 0 at that point, because it would not be able to switch directions. The acceleration is actually less than 0 because it goes from a positive to a negative value. That means the object turned around. So the acceleration turning around means that we're opposing the velocity, going in the opposite direction. So it goes positive to negative. Our acceleration is in the negative direction. It's actually trying to pull it back towards the center. Same thing down here, but exactly opposite. We're going from this point to this point, the velocity is less than 0. And from this point to this point, the velocity is greater than 0. So we go from a negative velocity to a positive velocity. That means the acceleration has to cause this change. So at this point right there, the acceleration is not 0. It's actually a positive value. Same thing over here. It's the same as the first case. We have the acceleration is actually going to be less than 0. At these points right here, when it's at 0 displacement, it's a spring, right? So spring is ma is equal to minus kx. At 0 stretch, we have 0 acceleration because the spring does not provide any force, which makes sense because at 0 place here, we go from a negative acceleration to a positive acceleration. We had to cross 0 at some point. So these dots are a 0 acceleration. So let's look at the question again. It says, we want to know at some point the oscillation of the mass has 0 velocity, all right, but has acceleration. Oh, that's true. Definitely true. So I is true. So that can't be there and can't be that one. Second point says, at some point of the oscillation, the mass has 0 velocity, those 3 points, but has 0 acceleration. That cannot be true because every point that has 0 velocity actually has the maximum acceleration. So in my choices, C is the correct answer. Only when we have 0 velocity, or when we have 0 velocity, we always have an acceleration, a non-zero acceleration.